In this demo, we will apply a technique which allows us to replace a character or characters within a string, and we'll learn how to remove part of a string. Due to the immutability of strings, we're not really modifying the existing strings here, but instead creating a modified instance with the desired changes applied. The first new business requirement we'll tackle is that we've been asked to ensure that the processed data uses a consistent UK English spelling within product names. Currently, one example has been identified where the US data has a different spelling for the word colour that we'd like to adjust. To normalise our data and use consistent spelling for words, we'll update our methods in the historical sales data class. After extracting the product name, we can use the replace method on the string instance to replace any occurrences of the US spelling of colour with the UK spelling. This returns a new string instance with the replacement applied. Replace can be used to replace occurrences of either a specific character or a string of characters. We'll copy this code and use it in the try create from row method as well. With this straightforward change, we should have met our requirements. We'll add a conditional breakpoint to see if this has worked. For the condition, we'll check if the extracted product name contains the US spelling of colour. We can debug the application, and our breakpoint is hit once the US data processing begins. The product name, extracted from the row, uses the US spelling. Stepping through, after the replace method call, the spelling has been replaced. We've been handed some additional requirements from the business about the product information data. We've been asked to support colons in addition to hyphens as valid separators between the sales code and the SKU. An additional format for product data has been identified, which is valid and is something we should support. We'll review the details of that format in a moment. Finally, we've been asked to ensure that the sales code portion of the product information only uses numeric digits. Any non-numeric characters should cause the data to be considered invalid. Some data in our historical files may include an alternative format for the product information. Here is an example. The product information begins, as usual, with numeric digits for the sales code, followed by a hyphen. Following the hyphen separator, there is an extra prefix formed of a lowercase letter and a hash. We should treat this as valid data, but strip this prefix from the parsed SKU. Only a single lowercase letter character is supported in the prefix. In this format, a suffix is also provided inside parentheses. We should strip this suffix from the parsed SKU. In this example, the parsed sales code should be 123, and the parsed SKU should be AC65. We'll need to add a couple of extra test cases to represent data from our new requirements. I'll copy this test data and paste it into the end of the list. I'll make one change to the input string, replacing the hyphen with a colon. Our implementation is expected to parse this successfully. We'll add another test case where the input string represents the more complex format that may appear in some data. With this format, we expect the code to equal the string 123 and the SKU to be AC65. We'll add another test case by copying this one and replacing the lowercase b with an uppercase B. Based on our business rules, such codes are considered invalid. We'll add a final test case to validate our last updated requirement, specifying that only numeric digits are allowed in the sales code. The input string for this test case includes a letter in the sales portion. We expect parsing to fail and return an invalid product info. If we revisit the product info class, we can update the parse method implementation. As with many string manipulation requirements, we could approach this in several ways. We'll achieve our requirement using an overload of the replace method, accepting chars. It's important to bear in mind that this will cause an additional small string allocation when a replacement occurs. We expect such replacements to occur very infrequently, so we won't worry too much about this allocation for now. We'll return to this at the end of the clip and consider how to avoid it entirely. Let's now add some parsing code to deal with the additional skew requirements. After extracting the skew portion of the string, we'll check if it requires any special handling. If the first character is classified as a lowercase letter and the second character is equal to the hash character, then we need to handle this less common formatting. We don't require the prefix in our final skew, so we'll strip the first two characters here. We could either use a substring or a range. We'll extract a string starting at position 2 until the end of the string. We'll also include an else condition to handle any other situations where a string includes a hash but is not preceded by a single lowercase letter. In such cases, the product info is invalid. We may also need to strip any text inside parentheses at the end of the product info. We'll check if this situation occurs by getting the index of the open parentheses character. If the index is not equal to -1, we have parentheses on the string. In this case, we'll use another string method to remove part of a string. The remove method on a string instance takes a start index and optionally a length. Because we want to remove everything from the open parentheses position onwards, we don't need to specify a length. Of course, we could also have used a substring or a range here as well. We have a final requirement to meet, which should ensure that only digits appear in the sales code. We'll use the link any method to check this condition. If any character from the sales code is not a digit, we'll return the invalid instance from this method. These changes should meet our requirements, so let's rerun the tests. Each test case has passed, which is great news. Before we move on, I said we'd return to the use of the replace method and look at a way to avoid the potential extra string allocation. The separator within the product info is not returned as part of the final product info instance. Rather than replacing it at the start of the method, we could instead process conditionally for either case that we expect. Let's comment out this line to avoid replacing any colons. We can instead make two small changes to the code. We can extend this condition and say that when a string does not contain a hyphen, and when it also does not contain a colon, then it's invalid. If either character is present, then we continue to parse the string. The only other change is then to split on the appropriate character. We can use a ternary conditional operator to assign the parts array. When the string contains a hyphen, then we'll split at a hyphen. Otherwise, we'll split at a colon. These changes ensure that we handle either supported separator, avoiding the need to potentially allocate a new string by using the replace method call. During string parsing and processing, there are often ways to avoid allocations caused by the immutable nature of strings. It's not always necessary to be too concerned for small, infrequent allocations, but it can sometimes make a worthwhile difference for performance at scale.